Welcome to Mobility Learning Center. Today I will present you about the kinetic molecular theory of gases. Is grade 9 chemistry, unit 5, parts number 4. Okay, objective of this lesson. By the end of this lesson, the students will be able to explain the assumptions of the kinetic molecular theory of gas, describe the properties of gas using kinetic molecular theory, describe the behavior of gas by using the variables volume, temperature, and pressure. Kinetic molecular theory of gases. The particles in an ideal gas are very widely spaced and they are in constant random motion. The pressure of a gas is the result of the continuous collision between the particles and the walls of their container. Assumptions of the kinetic molecular theory of gases. The particles are in assumptions of the kinetic molecular theory of gases. The particles are in a state of constant, continuous, rapid, random motion, and therefore they possess what kinetic energy. The motion is constantly interrupted by collisions with the molecules or with the containers. The pressure of a gas is the effect of these molecular impacts. The volume of the particles is negligible compared to the total volume of the gas. Gas are composed of separate, tiny, invisible particles called molecules. Since these molecules are so far apart, the total volume of the molecule is extremely small compared with the total volume of the gas. Therefore, under ordinary conditions, the gas consists chiefly of empty space. These assumptions explains why gases are so easily compressed and why they can mix so rarely. The attractive force between gaseous particles are what negligible. There are no force of attraction or repulsion between gas particles. You can think of an ideal gas molecule as behaving like small billiard balls. When they collide, they do not stick together, but immediately bounce apart. The average kinetic energy of gas particles depends on the temperature of the gas. Because the molecules have different velocities, they have different kinetic energies. However, it is assumed that the average kinetic energy of the molecules is directly proportional to the absolute temperature of the gas. The absolute temperature of the gas means the temperature in Kelvin scale. At any particular moment, the molecules in a gas have different velocities. The mathematical formula for kinetic energy is kinetic energy equals to half mass times velocity square, where m is the mass and v is velocity of gas molecules. Okay, let's summarize the main points of the kinetic molecular theory of gas. The particles are in a state of continuous, constant, rapid, random motion. Therefore, the particles of gas possess what kinetic energy. Number two, the volume of the particles is negligible compared to the total volume of the gas. Number three, the attractive force between the particles are negligible because gaseous particles are far apart. Number four, the average kinetic energy of a gas particles depends on the temperature of the gas. Review questions is a multiple choice type questions. Question number one, which of the following assumptions explain great compressibility of gases? A, the actual volume of the gas molecules is negligible. B, there is no force of attraction. C, particles are always in random motion. D, different particles have different speeds. The answer is A. Gas molecules are considered as point masses because the actual volume of a gas molecule is negligible when we compare with the total, when we compare to the space between what the gaseous particles. So these assumptions explain the greater compressibility of what gas. Number two, gases belong and occupy all the space that is available to them. A, contract, B, compress, C, expand, D, shrink. The answer is C. At normal temperature and pressure, there is no force of attraction between the gas particles, so they expand and occupy the space that is available. This statement supports the assumptions of the kinetic molecular theory. Number three, gas do not have a fixed shape. A, true, B, false. The answer is A. Particles do not have a fixed shape because they are always in random motion and particles never occupy fixed position. They keep on moving and never occupy a particular shape. This is the reason to prove that the above statement is what's true. Number four, why do you think the pressure is exerted by the gas on the walls of the container in all directions? A, they consist of identical particles. B, collide with each other during random motion. C, lack of definite shape. D, more force of attraction. The answer is B. As the particles of a gas travel in straight lines and move in a random motion and collide with each other and also collide with the walls of the container, the pressure is exerted on the wall of the container is in all directions. Number five, there is an increase in temperature of an object, then the kinetic energy of the object, A, decreases, B, increases, C, remains the same, D, it is not related to temperature. Okay, the answer is B. From the kinetic molecular theory of gas, we can know that the kinetic energy of an object is directly proportional to the absolute temperature of the object. So when the temperature of an object increases, obviously the kinetic energy also what increase. A direct relationship between kinetic energy and absolute temperature. The absolute temperature means the temperature expressed in a Kelvin scale. Number six, which of the following is not a postulate of kinetic molecular theory of gas? The kinetic molecular theory of gas has four postulates. From these four, which one is not a postulate? Okay. A, the actual volume of gas molecules is negligible. B, there are high force of attraction between the gas molecules. C, collisions are elastic in gas molecules. D, kinetic energy of gas molecules is directly proportional to the absolute temperature. The answer is B. According to kinetic molecular theory of gas, there are no force of attraction between the particles of gas at normal temperature and pressure. This is because gases expand and occupy all the space available. Okay, this is a question. Okay, thank you for watching. See you later. Please like, comment, subscribe, and share my YouTube channel. Thank you very much. Bye-bye.